Now let's try the same thing but with right-hand rectangles. So we're still going to use our delta x by dividing the interval from 1 to 3 into 4 equal pieces. So 1/2 is still our delta x. So now my first subinterval is from 1 to 1.5. I'm going to go to the right endpoint at 1.5 and go up to the curve, and that will determine the height of that rectangle. And then my next subinterval is from 1.5 to 2, and I'm going to go to the right endpoint at 2 and go all the way up to the curve, and that's going to determine the height of my rectangle. My next subinterval is from 2 to 2.5, and I'm going to go to the right endpoint at 2.5 and go up to the curve, and that's going to determine the height of my rectangle. And then last but not least, my final fourth subinterval is from 2.5 to 3, and this time I'm going to go to the right endpoint at 3 and go all the way up to the curve. Again, this is the function f of x, and that's going to determine the height of my rectangle. So now I'm going to estimate the area under the curve with 4 right rectangles, and I'm going to call their areas A1, A2, A3, and A4. But FYI, if you want to look back at page 1, what I'm now showing as area A1 is going to be the same as what area A2 was on the previous page. In other words, the height of that rectangle is f of 1.5. Okay, and rectangle A2 on this, in these right rectangles, has the same area as rectangle area A3 in the previous example with the left-hand rectangles. So just because we did A1 and A2 before, let's calculate area A3 and A4 on this one. So area A3, the height of my rectangle is f of 2.5. So at x equal 2.5, I go up to the curve, and whatever that function value is, that is the height of my rectangle. And then the width, of course, is delta x. So f of 2.5 is 33.625, and if you have your calculator or Mathematica handy, you could check that. And when we times that by 1/2, we get 16.8125. And let's look at area A4. So again, I'm looking at the right endpoint of the subinterval from 2.5 to 3. And that would be at x equals 3, and I go up to the function to look at f of 3 as the height of my curve, the height of my rectangle, and then times the width, delta x. And in this case, f of 3 is 51 times 1/2, or 0.5 if you prefer, and that gives 25.5 as area A4. So note to self. Right, and again, I guess I should have written in this is height times width once again. So in the table, this is the exact same table that was on the previous page, even though that one said left-hand sum and this one says right-hand sum, but I still have height and width and area, which is height times width. And in this case, the 6.1875, which was previously area A2, is now my first right rectangle area, and 10.5 is my second right rectangle area, and 16.8125 is my third right rectangle area, which was my fourth left rectangle area on the previous example, and now my fourth right rectangle area is 25.5. So now I have another different estimate for the area under f of x using 4 right-hand rectangles. I can add these together, these 4 areas. So I've got 6.1875 plus 10.5 plus 16.8125 plus 25.5. And if you add those together, I dare say you get 59, and you are free to double check. And here's another thing you could do. I'm going to say this but not write it down, but you might want to write it down and see if you can understand it. If I take my left-hand sum from the previous page and subtract 3.5, then I will have A1 plus A2 plus A3, and then I can add 25.5 onto that, and I should get 59. So if I take the left-hand sum from the previous page minus 3.5 plus 25.5, I should be able to come up with 59. Okay, now we can take an average. So again, you can see in this case that this right-hand sum area estimate is an overestimate. I have some area here, and some area here, and some area here. That's counted in the area I just calculated, but it's clearly not area that's under the curve, right? So that is extra area. So this is an overestimate. So the true area under the curve is somewhere in between what we got previously, 37, and this 59. So maybe what we should do to get a better estimate is take the average. So the left-hand sum, that's what we call it using the left-hand rectangles that we did on the previous page, is 37, and the right-hand sum is 59. And if we average those two together, we can get a better estimate of 48. Okay, so you might just think about what it is about the function that lets you know that the left-hand sum would be an underestimate and the right-hand sum be an overestimate, right? And the fact is it has to do with the behavior, right? So since f of x is increasing, the height I get by using the left endpoint is going to be too low, and the height I get by using the right endpoint is going to be too high. So whenever I have an increasing function, the left-hand sum will be an underestimate, and the right-hand sum will be an overestimate. And in general, I can always take the average of the left and right-hand sums to get a better estimate than either one gives me individually. Do I think that 48 is the exact correct area under the curve? No, not necessarily. But it's a better estimate than either 37 or 59.